Welcome everyone to our 10 a.m. session, Impactful AI, Creating the World We Want to See. We are joined today by our speaker, Richard Socher, Chief Scientist and Executive Vice President at Salesforce, and our moderator, Bridget, the Vice President of Customer Success at LiveRamp. Welcome to both of you and thank you for joining us.
Great to be here.
Thank you. Happy to be here. Hi, everyone. Welcome to the session, Impactful AI, Creating the World We Want to See. The MIT AI conference is far and away my favorite of the year. Many thanks to Teddy Lee and Shuja Keen, who have dedicated tens of thousands of volunteer hours over the years to make this and hundreds of stellar events possible for the MIT community and for the many friends of MIT. My name is Bridget Brett, and I am your host for this session. I have 2 degrees from MIT, a bachelor's degree in ocean engineering and a master's degree in management. My career has been focused in business and operations, first in the energy industry, and now in tech at LiveRamp, a data connectivity platform. LiveRamp enables companies and their partners to better connect, control, and activate data to transform customer experiences and generate more valuable business outcomes. Now, our guest speaker. I am pleased to announce Richard Socher, who, if not sitting here with us right now, would likely be flying at 11,000 feet in his paramotor, teaching a deep learning course at Stanford, or directing the AI research at Salesforce in his role as chief scientist. And he may share with us that he's about to embark on a new adventure with a startup. Richard was CEO and founder of MetaMind, a startup that was acquired by Salesforce in April of 2016. MetaMind's deep learning AI platform analyzes, labels, and makes predictions on image and text data so that businesses can make smarter, faster, and more accurate decisions. Richard has an astounding 62,000 academic citations. He is also the ideal speaker for you all, as he much prefers audience questions from you all to my own. So start posting your questions now, because we won't have time to get to every question, and I'll do my best to pick the most intriguing ones for Richard. We're going to cover some truly impactful topics today, including AI ethics, AI for good, AI for healthcare, and maybe some more if we have time. So let's get started with the questions. With great power comes great responsibility. Many without the power to control these artificial systems are fearful of them. Even Elon Musk, who arguably is in the power position, is even still among those warning society that we should all be fearful, as he believes that AI will soon become just as smart as humans, which can compromise our very own existence. Stepping back from the existential fear that some have with AI and to the social justice movement of today and the quest for an equitable, responsible, and ethical society, the question of AI ethics is a significant one. So, Richard, how do we ensure that AI advancements are on the right side of history, avoiding system biases?
Great question. Great to be here. Obviously Elon is super smart, but it is also kind of funny how he says, "Oh, AI is such a troublemaker and potential, issue for humanity," but then he does also strip it into all his cars over the internet. And so we have to, I think, acknowledge here that there's this dual state that AI is in. Where on the one hand, it's like the new electricity. We know how it works for 80% of very useful business applications. And we need to acknowledge that it's non-trivial. You need to set it up. Sometimes there's a consultative component and data labeling and so on. But for the most part, just like current or voltage and electricity, we figured out the basics and we can make it useful. And on the other side of this dual state is the AGI state, where we're still continuing to work on research. We're still trying to make AI be able to train with much less data, be more intuitive, be able to learn from few demonstrations and reinforcement learning and so on. And we're still trying to capture this elusive artificial general intelligence goal, though how far we are from that, the opinions wildly differ. I think a lot of things that we can do with a lot of training data we'll get a lot better at, but eventually there will be certain upper bounds on the AGI side. Like in the end, people have a set of predetermined objective functions as we're growing up. First you want to just have attention as a baby, you want food and basics, and at some point you want an iPad. And the question is, how did you get there? How do people set these different objective functions? And is it enough to have just one major objective function like survival and so on? And does that make sense across one individual or population and so on? So a lot of exciting philosophical and hardcore research questions on the AGI state, and a lot of interesting business challenges on the electricity state in the right now. Now, in terms of what is important for us to get it right, we actually at Salesforce have thought a lot about this. We want to make sure our AI is ethical, and it's a highly complex question with a lot of issues around several of these. And I knew the question would come, so I prepared the slide here just to give you an overview of at least 5 of the pillars that we think are sensible to have for every AI ethics problem. First, it should be responsible in terms of safeguarding human rights. The Human Rights Charter from the UN should be such that we can all agree on that this is something that AI should adhere to as well. And of course, it needs to be private in terms of the data that flows into the AI. But then more concretely, I think, this first one is obviously true for almost every technology out there. No, it is true for every technology out there, not for almost. It should be accountable as well. We should seek and leverage the feedback. AI is not logic. It's not 100% correct all the time. And especially as it comes to more and more important decisions about people's lives, we need to allow them to say, I don't think this was right for me. And they should be able to give feedback, and there should be continuous feedback loops. Even something as simple as service, you would need to, when you have a service call center over the phone, or over email, over chat, you need to be able to say this doesn't work and be able to give that feedback. Now, it should also be transparent. As you develop these algorithms and as they change and try to change human behavior too, especially, it's important to tell people why it's making a certain recommendation, for instance, and basically have that transparency. And the last 2 are empowering. We should try to work on AI empowering economic growth and employment for our customers. And in some cases, that's easier because AI just makes some people more effective and efficient at their job. In other cases, it will challenge the certain existing jobs and how exactly they're performed. And in some cases, we might just need fewer of those jobs in the future. Now, some people who are already thinking the AGI is going to happen tomorrow think, oh my God, all the jobs will be gone. There's nothing for us humans to do in the long distance future. But for people like that, I want to maybe ask for a bit more humility in our ability to predict the future. It's very hard to be that certain about things that are 40 years out. And just to give you an example that I came up with was like, imagine the internet is just being invented. You have the first TCP IP packages be sent around 40 or so years ago, and ARPANET, and people ask, like the leading experts of networking and lower level TCP IP packages, what's the impact of jobs of this new internet you're playing around with, you're working through on the research side on jobs? What's the impact of the internet? 0 of those experts back then predicted that we'll have social media marketing positions. And yes, the people who had to connect one phone line to another physically don't have jobs anymore. And people who had to run around on horses don't have jobs anymore to deliver certain kinds of simple lettered mail. At the same time, we have so much more economic growth because of it, and there's so many new kinds of jobs. So that is, again, that dichotomy between these 2 states. And lastly, I think we need to respect all the different values of those that are impacted. And this is a pretty big one. I think biases are everywhere in technology and in AI systems as well. There are systemic biases. There's the bias of just like, if you don't change anything, you're basically protecting the status quo. And there's a lot of interesting research that is going on. There are other people who are much better equipped at talking about this, since they're really focused on that in their research, like Tim and Gabriel, who's currently at Google, who are really thinking about biases. And Of course, there's the systemic bias issues. There's also issues with equality and diversity in our field itself. So we have a certain selection of what kinds of tasks we are working on. And then, of course, there's also data set bias. If you allow somebody to train an AI algorithm based on past behavior, there are likely biases in that. And so we need to be extra careful on trying to improve that.
Very helpful, Richard. And we did have audience agreement in highlighting the accountability section of this framework. So that's very helpful. And of course, yes, important for our society to really get it right, especially with the biases piece that you mentioned. So thank you for that. To switch gears a bit to a recent project of yours, another project that uses reinforcement learning that's really exciting and is called the AI Economist. It's going to be open sourced soon, so those on listening should take a look. It's an awesome example of AI for the good as you seek to solve income inequality. So I'm curious to hear, Richard, what system did you create and what's your vision for the potential impact that this could have on society?
Yeah, I'm really, really excited about this project. It's called the AI Economist, and it's essentially an AI framework for economic policy design. Now, what we're actually trying to do here is we try to build not something that a lot of other organizations do, it's like playing zero-sum games or war games, because we think that AI and the research that line of work pushes might not be as peaceful as some of those organizations could hope. So we're thought about, we came at this project from different angles. One is, what's the biggest issue of our time? It's, I think, to a large degree, a lot of other issues that we have, like racism and sexism, stem also from economic inequality that's underlying that. If you're economically empowered, it is much easier to get away from a lot of other systemic issues in societies all over the world, not just the United States, but other continents and so on. And so when you look at the history, economics is a major piece of that. And we also looked at areas where AI has not had yet as much impact on. And people used to think, oh, economics is just impossible for AI to have impact, but we think that's not true. And then thirdly, this RL is also a really interesting research area, in particular in this case, because in almost every reinforcement learning project that you may have seen, like Go or chess or certain computer games, the objective function stays the same for all the agents. You have to win, the rules of chess don't change. Here, we have a two-level reinforcement learning problem where first, you have separate AI agents. You see them here in this little slide. They're trying to maximize their own utility. They want to build houses, collect resources, trade with one another, and a couple of other things that are fundamental in economic modeling. Like they have utility functions. At some point after working 6-7 days a week, you don't want to work anymore. You could work anymore, but you have sort of diminishing reward for that, and you want to have a weekend. So some of these things aren't modeled in games, which we would have liked to use, like Civ or others, but it didn't really make sense because they don't model this idea of utility. So then these agents are optimizing their own outcomes, just like most people are optimizing for their own outcome. And then the AI economist sits on top of that and tries to optimize the overall system for a product between equality and productivity. So productivity is relatively simply modeled by just everyone's economic output in terms of whatever coins, and then equality is measured as 1 minus the Gini index in order to optimize how equal the outcomes are and the wealth is across this simulation. And now what's interesting and challenging here is that as the AI economist changes the taxes, the objective function changes and the setup changes for each of the agents. And just like people, we wouldn't want to have every couple of weeks our tax system change. It gets really confusing on how to optimize for certain things. And so it's really hard for the RL agents. What's amazing here in the sort of on a very high level is, imagine we could play out a certain tax schema or a certain setup and framework over millions of years. And instead of doing human error and trial and error with real people, we could try this out and then ask the AI, what do you think could be a better taxation scheme? And I think this goes at the very core of like civilization and human society. And it's that nice mixture of the two states of truly transforming AGI types of questions of what's the best way for us to live together, but it's also very concrete. And we'll do an AMA on Reddit on August 7th, and we'll work together with the community eventually to really get the simulation to be highly realistic. And I can't wait to see the results as we're making the simulation more and more realistic. They're very concrete effects that we don't yet have modeled, like inheritance. The agents in our simulation, they don't die and have babies and have multiple generations, but we know that inequality is to a large degree affected by inheritance and rich get richer schemes. So it's an interesting question of how to model that. So there's still, the simulation isn't yet realistic enough, but already we see some very interesting results, and I'm really excited for this line of research.
That's awesome, Richard. Yeah, I'd be curious to see what sort of disruptions and events you could add in other than inheritance too, right?
That's right. Economic or pandemic modeling are definitely high up on that scale too. Yeah.
Exactly. Yeah, there's almost too many unknowns with different regimes. So super exciting work. Thank you for sharing that, especially applicable given that you were speaking about taxation policies, and this week in the US, taxes were due after the extension with COVID. So pretty interesting project. So let's also transition, speaking of COVID, to a project that you're working on in AI in healthcare, which is really interesting. So when we think of COVID, there's an image I think that all of us have in our minds of the COVID-19 spike protein that enables the COVID-19 to gain entry into our cells. So you've developed with your colleagues a high capacity language model that's trained on 280 million samples from the largest protein database available. And of course, that includes the COVID-19 spike protein that we all can't get out of our minds. So how can this model that's called ProGen be applied as researchers seek to understand more about COVID-19?
Yeah, it's another project I'm so excited about that I have a slide prepared for it. And it's a new kind of model that basically, this idea of language. So what is a language model? A language model is a model usually used for natural language that just predicts the next word. And that is such a simple objective function, but it's really beautiful because it allows you to train on all the text data you can get your hands on. And hence these language models also can start to learn a lot of interesting world knowledge. When you say, oh, I went to Paris and then I got into A, and it's like, well, in order to answer that question, you need to gather a lot of statistics. Essentially, it's co-occurrence statistics that we're capturing here. Well, but in these co-occurrence statistics, there's a lot of world knowledge. Like you're probably getting into a taxi or an airplane, and then what this means, and being able to predict the next word actually is a pretty interesting and tough challenge for humans. In some cases, it's just a little ambiguous, but in other cases, we all agree this is the next word. And this is very useful originally for things like speech recognition, where if you would like to know the price of wood, in that sentence, there are two woods, the auxiliary verb and the noun of the wood from trees. And so you would want to be able to basically know which one is which in that sequence. So that is sort of the history of language models. For speech recognition and machine translation, they were used. But now we realize they learn incredibly useful representations of language. They capture so much world knowledge. And it's been really, really exciting to see that applied in natural language processing. But in OpenAI, for instance, and also in our case, we started with contextual vectors and had one of the first lines of work by Brian McCann on contextualized word vectors, Cove, which then became Elmo and BERT, and were extended in using language modeling instead of machine translation. But what we also thought here is we all understand human language. Nobody really understands the language of proteins that well. It's very hard to know what this next protein. We're not evolutionarily made to be able to predict that next protein sequence. Now, here we're training this on 270 million protein sequences, 280 or so, and then predict the next one. And what that means is, because it's also controllable, like our controllable language model, CTRL, we can now say, let's change some of the codes and ask the model what would be a good protein for that set of functions and for that kind of organism. And indeed, it's a little too early to talk about the details, but we're very excited about applying this also to drug design and medications, and particularly to COVID. But really, it's in terms of synthetic biology and helping people and the environment and so on, the sky's the limit for this kind of technology. I'm really, really excited about it.
That's awesome. And I know we have a few minutes left, so we're going to do something atypical, which is actually return to our last subject, because that's where a couple audience questions have come in since we moved to the ProGen topic. So to go back to the AI economist for a minute, when you're thinking about the economic policy design, really just to hear your open and honest thoughts, Richard, about, what do we need and how can you model that in? Like, do we need in the current state a Manhattan Project or a Green New Deal? What sort of mechanisms are you able to factor in as you are designing through AI Economist?
It's a great question. So there are a lot of different ones. We have a long list, and I think either it's an open source project like Sadie at Home, where people will provide compute, but also provide the ability to change the simulation. I think it's extremely important that this kind of project, AI Economist, is not in the hands of just a single organization. A lot of organizations, claim to be open and then might not be, or they eventually have pressure to stay alive as an organization. So we made sure, and I'm really happy that Salesforce supported us in this line of work, and that we have Mark Benioff as an amazing CEO who helps allowing us to work on these kinds of projects. And particularly, AI Economist, we did not patent. Most every paper you see from every industrial research lab usually has a patent associated with it. We did not patent this line of work, and we will make it open source. Imagine a future where somebody says, I have this access to this amazing compute and to this amazing model that will tell all of us how we should, get taxed and other important factors. And then maybe they had a bug in there. Maybe they made the simulation such that it gives the output they want to give. So the only way this kind of line of work can work, this line of research can work, is when it's completely transparent and you see why the AI has come up with these. You can look at and evaluate the simulation, and then you can add your own factors. You're like, maybe there was a minority that wasn't properly captured in the simulation, and it doesn't have the proper context in the simulation. And you need to be able to change that and see how the outputs would change of the simulation. So I think the transparency and community aspects of this are super crucial. And even if we could, we shouldn't try to say, this is how exactly we think everything should be modeled. It should be a collaborative effort across universities, but also across anybody else who can code and provide useful information to that. And then together we can run the simulations as well in a big project. Now, would this project benefit from more support? Of course, it can't hurt to have more support and have some governments come together and support this kind of work. But in the end, I think a lot of people and individuals from diverse backgrounds need to be able to collaborate on.
That's awesome. And I think there's a question from the audience also about how do we make the AI Economist explainable, which highlights to some of your points. It's how do you defend it? How do you make it defensible and explain it once it's run its course?
Right. I think there are different elements to explainability. In some cases, you want to really know high level how something happened. And in that case, you can actually look at the simulations that the framework has gone through. And you can look at the various alternatives that it has tested, and then what happens in those alternatives, right? It's something that's really hard to do in the real world on a massive scale. It's basically impossible. And then there's some low level things where you might not know exactly how, but it's also humans at the end of the day don't really know why do you think this is that person? Well, they have this kind of hair. How do you know this is hair? Well, it's a short line. How do you know it's short? Like at some point we don't have conscious access to V1 and V2 of our visual cortex or our motor cortex. Why did you move the steering wheel 3 millimeters and not 4 millimeters to the right? It's like, you're roughly in the middle of the lane. And you don't really have access to all the explanations for every single muscle in your body. So we have to differentiate, I think, between some low-level explainability of the AI and some high-level explainability of the major factors.
That's awesome, Richard. Your impact on the world of AI is incredible, and the adventures you capture and share with us on your Instagram at Richard_Explore are as well. So people should check that out. Thank you for taking your time today, Richard, and thank you to the audience as well.
Thanks. Great audience questions. Until next time.
Thank you, Richard and Bridget, for your time today. I think we had a really engaged audience. If you're joining us for the next session, the future of streaming TV, something we all, myself included, are very familiar with these days, that will start in 5 minutes. So see you there.